Hi there. Welcome to today's 6th edition of the Insider Threat Podcast. Today, we're going to be talking about how attackers are stealing your credentials with Mimikatz. I'm your host, Jonathan Sanders, CTO here at StealthBits. And joining me again is Jeff Warren, SVP of Technical Product Management. How you doing today, Jeff?
I'm great. Thanks for having me.
All right. Once again, for those of you who have not met Jeff yet, he's our cybersecurity expert. He's been in the trenches helping people for years with this stuff. And how we got to talk about this topic, if you're not aware, is we've been doing a series of blogs on attacks, focusing on Active Directory infrastructure and how people are using that to do bad things. And what the latest series focuses on is a tool called Mimikatz. Now, if you've been watching before, you know we've talked about Mimikatz in the past as part of the healthy breakfast of doing bad things on the inside of the world. But this series focuses on Mimikatz itself, all the different ways that you can use Mimikatz to basically learn about what credentials are on machines, steal those credentials, pass the hash, and do lots of other nasty things. And it also goes into a lot of utilities that people have built around Mimikatz, because it's not just that Mimikatz itself is dangerous, it's that people have taken Mimikatz, packaged it up into toolkits that do what it does on scale, allow you to, run around in the enterprise sort of at will and grab credentials and do bad things with them. And we've even seen things like it being packaged up, and we'll talk about that when we get to the questions. But that's our topic and how we find ourselves talking about it today. As always, what I'm going to do is I'm going to grill you, Jeff. That's the way the format goes. For those of you who don't know. So, by the way, this is going to assume that you might have already read the blog posts. So if some of these questions, if you're wondering about what I'm talking about, that would be a great thing to do. So, Jeff, in all the series, you talked about a lot of different attacks, a lot of cool names. And the one that I think sounds the scariest, if you're just hearing about all this stuff for the first time, is the skeleton key. It's just because essentially, as a skeleton key description would have it, it allows you to basically go grab and become any user. But it requires that you get domain admin first. So how scary is it to actually have a skeleton key attack if the attacker already had to grab domain admin rights to make it work? Why is that still scary? Or maybe it's not as scary as it sounds. Help us understand.
Yeah, so I think in reality, the attack itself is as scary as the name. And basically what happens is you're running malware on your domain controllers that's injecting into LSAS, and it allows LSAS to accept a secondary password for any user account. And in the case of using Mimikatz, that password is hard-coded to Mimikatz. So why is that scary if you're already a domain admin? For two reasons, really. One, using Mimikatz and doing pass the hash, even if you have domain admin creds or great golden tickets, you end up living your life a lot in the command line interface and not so much in the interactive logons of the world, like using webmail or logging into remote desktop. So if you can go from pass the hash to knowing a password that you can type in anywhere, it opens up a whole new avenue of attacks. So you don't just have to live at the command line interface. Most of those other places don't accept password hashes. The second reason is for persistence. You can basically get back in if you ever get kicked out. If you do compromise a domain admin, somebody catches on, they reset the accounts, they reset the KRB TGT account a couple of times and remove your access. Let's say the skeleton key is there as your backdoor in. Now, every time you reboot the domain controller, it might go away, but there's ways around that too. You can use registry keys, you can use scheduled tasks, you can sneak it in other ways so that when it boots back up, the skeleton key re-injects itself. So it's a way for an attacker to open up one of several backdoors to try to keep themselves from getting kicked out permanently from a domain.
So as always, right, there's a little cheating going on in these podcasts, right? I sort of know the answers to the questions. I'm looking for your perspective. But what's interesting is that when I think about the skeleton key thing, the scariest thing to me is I've worked a long time in identity management, and a lot of people have taken Active Directory and made it the single sign-on hub for their entire enterprise. And I mean, I think of all those people I knew that actually use software that I used to be associated with to do things like make Active Directory the sign-on for their SAP system, right? And they have all their critical IP in SAP, and this skeleton key attack could essentially allow them to log on to SAP as anyone, that's kind of frightening. You're right. Okay, so completely different angle, right? We've seen malware and ransomware using Mimikatz code, right? So it's basically taken the code of Mimikatz, absorbed it, and then essentially attacked at scale, right? That makes sense, right? Because you use the Mimikatz code to do lots of things with credentials, and that helps them go lateral and be persistent and do everything that they want to do. You go into tools like Empire, DeathStar, CrackMapExec, and these blog posts, do you see the bad guys using those toolkits the way they would use Mimikatz? Or is that really more of the white hat, the pen testers who are using these toolkits to get this stuff done, and the bad guys are using other stuff?
Yeah, you're not going to see them using these exact toolkits. Just like with Mimikatz, when we've seen variants of it recently, like the Petya ransomware, they're not packaging up mimikatz.exe. They're taking source code from it, inspired from it, and packaging it up in their own tools the way that they see fit. And I think that these other tools that we go through, like DeathStar and Empire and CrackMapExec, they're more to showcase the attacks, how they work, to bring it to the attention of the security researchers and white hats, so that you can see how PowerShell injection works, how you can bypass these controls, leveraging PowerShell without actually launching PowerShell.exe, which is one of the cool things that Empire shows you. And now attackers could do that. If they wanted to embed that in their attacks, they can. It's not that difficult. You can look at all the source code and see how it's done, and then come up with your own protections to make sure if an attacker does exploit that, you're ready.
Yeah, it is interesting, actually, to put my programmer hat on and look through the source code of some of these GitHub repositories and see. I mean, the scariest part is just how simple some of this stuff is. That especially DeathStar. When I was looking through the code there, I mean, it's just an automation engine. I mean, it really, it's not doing the scarier code is in Mimikatz, of course, and that's the focus, right? But to see all the power DeathStar has, and then to understand that really all it did was take it and script and automate a lot of stuff that had already been out there, it shows you what the bad guys can accomplish, right? It does get scary. So one of the things that this series does is talks about how you can avoid some of these problems using the native capabilities within the Microsoft platform. And one that fascinated me, and something I didn't know, by the way, until I read your blog posts, so that you taught me something with this one, was that you could get a lot of this stuff done, and people are specifically aiming at PowerShell v2 as a platform because a lot of the newest security features are all requiring version 5, and a lot of people still apparently have PowerShell version 2 installed and ready to go on their systems. It's enabled, and they can actually rely on that to some sense. And it's funny, I was looking through some of the stuff that we didn't actually cover in the blog post. I was out there plumbing the depths, and I did see examples where people were going through and saying, if there's PowerShell version 2, then they follow this line of attack, and if there's not, they follow this whole other line of attack that's much more complex, because in the v2 world, it's simpler because the security controls aren't there. I mean, there may not be a very sage-like answer to this one, but I'm just curious, in your opinion, aside from scripts that are kind of old that might still be in production, is there any good reason to have PowerShell version 2 running out there on systems in production?
Yeah, so I think we covered and saw why attackers certainly want to have it enabled. There's plenty of good reasons there. You get to miss all the logging and all the protections, but why would an enterprise have that still enabled? And I think you covered the main reason is backwards compatibility. And even in my own lab, when I installed the Windows 10 systems that I was using for the blog series, Windows 2.0 management engine is still there and it's still enabled. So I think Microsoft's stance is not all 2.0 scripts are compatible with 3.0, 4.0, 5.0. So let's just keep this turned on. And also third-party applications that are written that may leverage PowerShell 2.0 as a framework. You don't want to break those when you upgrade your operating system. So it's turned on. Does it have to be? That's a harder question to answer, and one that each company has to look within themselves to see, what do I use and how do I use it, and what's going to break if I start to turn these features off to accomplish better security.
Right. And I mean, this has been a problem that not just Microsoft, a lot of vendors, but Microsoft especially has dealt with over the years, that the tension between, you have to give Microsoft credit. They've always been very good at backwards compatibility, much better, by the way, than a lot of other vendors. And but that also hurts them, right? Because that means that these sorts of things can crop up, especially in the security domain, where that backwards compatibility can be used against them. And it's a tough question. It's hard to balance those two forces. So speaking of tough questions, it's been interesting to see the reaction to our blog series, right? And I've been spending a lot of time both in the webinars and in emails and in customer conversations and in just direct communications we've had that you've seen as well, where people are reacting to the blog posts and they're saying lots of things. And one of the reactions that's really common, something that's been sort of a theme, is, if I stay fully patched, right? So I avoid all my known vulnerabilities that are out there, and I control local admin, right? And other kinds of administrative logins as well, too, but especially local admin. And I also put good practices in place so I don't have help desk guys leaving hashes all over the place, using restricted mode when I'm doing remote desktop and all that stuff. If I do those basics, then none of this stuff should matter for me. That seems to be the theme. If I do all those things, this Mimikatz stuff that you're talking about, this won't affect me. I'm immune to it. Now, I could poke holes in that right now, but I'm looking for you to take the first shot at poking holes in that, because I suspect that, though, by the way, those are all really good ideas, and to anyone listening right now, you should do all of those things. For those who think that's all you should do, well, let's hear what Jeff has to say about that, right? Is that all? Is that everything? Will that completely protect them?
Yeah, it's certainly the best place to start. If you get a compromised machine and they have admin rights to begin with, then you've reduced all the barriers. You made their job really easy. But if you restrict admin rights, then there's going to be many ways around it, and it's hard to keep up with all of them. Some examples we cover in the blog series, some we don't. But you look at things like group policy preferences, where you can have passwords that are stored that are using reversible encryption, so that you can get clear text passwords just from group policy. You don't need any admin rights to do that. Any user can do it. You can also scan for open file shares where there may be scripts or files that contain passwords inside of them. A lot of toolkits have that. Just look for regular expression to find where there's connection strings or other types of password credentials stored in files that are accessible. And users that you compromise, they may have access to things to do their day job that contain credentials or passwords if they're not storing everything in a nice, neat, organized way. So you don't need to be patched and up to date on everything to still be vulnerable. You can have these other vulnerabilities out there, and you should be on the lookout for them. But putting admin restrictions in place is definitely a great place to start.
Yeah, and I agree. It's interesting, right? It's one of those things where he was like, well, if I just do those three basic things, I'll be completely safe. And I'm kind of like, well, yes, you should absolutely do those three basic things, but all your premises are correct. Your conclusion is false. like all three of those premises, I agree with, but you got to do more than that.
Yeah, and I think just one to tie back to a previous blog series, one of the ones we've written about in the past is Kerberos thing, and that's just another good example of how you can request service tickets that you find with SPNs. You don't need any rights to do that, and then you can take them offline and brute force attack them to try to get to an elevated service count. And then once you have that, you're going to have admin rights somewhere. So there's many, many ways to get around that limitation of admin rights.
I mean, the way I think about it is, if you're not doing the basics, you're letting them sprint from start to end and, just totally exploiting you. everything you do puts hurdles in their way. And the more hurdles you put in their way, the more chances they're going to trip up, the slower they're going to have to go. So you've got a chance to catch them. You give yourself more chance to fight back, to catch them in the act, and to essentially be safer, right? That's the idea. Okay, so that's it for today. Thank you, Jeff, again for joining us. And thank you, everyone who's watching, for joining us on today's Stealth Bits Insider Threat podcast. Again, right, we've been talking today about how attackers are stealing your credentials using Mimikatz. If you'd like to learn more, please go to stealthbits.com, click on the blog, and you can see all the blog posts that Jeff has been writing here. As well, if you're interested in finding out if you are covering the basics well enough, you might want to check out our security best practices assessment. It's a free thing you can do. Checks the top 10 things that are typically wrong in environments, pretty much covering all the things we just called the basics. So you'll be able to help yourself fix things from the top down there. So that's it for today for the Insider Threat podcast. Thanks for joining us. Jeff, thank you again.
My pleasure.
All right. Bye, everybody, and stay safe out there.